let's go over the answers to the problems on the review. All right, so this first one here, we were given an equation and a lot of different types of questions here. The first one, it says make a right sum approximation. When it says a right sum, we are going to use rectangles here. Okay, rectangle approximation. B, we're going to use trapezoidal. All right, then we're going to use our calculator. Then we're going to find the percent error for both approximations. All right, so for both A and B, we need a delta x. All right, we need a delta x. So remember, delta x is B minus A over N. So the B is here, the A is there. So it's 3 minus 1 over 4, which is 2 over 4, which is going to be 1/2. So that's our delta x. So we're doing a right sum approximation. Okay. Now, what we need is we need to figure out what values of x we're plugging in. So we have our little line here where it's 1 to 3. And every 1/2 we're going to be putting in our x value. So 1 plus 1/2 is 1.5, plus another half is 2, plus another half is 2.5. All right, and there we have our 1, 2, 3, 4 rectangles we're going to use. Okay, so now to do the calculation, delta x for rectangles always goes on the outside. All right, we are doing a right sum. So here's our first rectangle, right? 1, it goes from here to here. What side's on the right side? 1.5. So you plug in 1.5. So e to the 1.5, because that's x, plus e to the second, plus e to the 2.5, plus e cubed. All right, we use all of these except the one on the left because we're doing right sum. That's the right side of this one. That's the right side of the second one. This is the right side of the third. That's the right side of the fourth. All right, when we do rectangles, we just use those once. We're going to add together, multiply by half, put that in the calculator, and see what we get. All right, and we get roughly 22.0694. I'll let you know what I want you to round to on the test. I don't really care if you put 22.07. That's also going to be okay. All right, so that's right sum approximation. Now for trapezoidal, all right, trapezoidal, remember, is 1/2 height base 1 plus base 2. So that's where you put the 1/2 always on the outside, then my delta x, which in this case is also 1/2, all right, because we're still doing n is 4. It's the same as the previous problem. Now what goes in here, we are going to use, if we have base 1 and base 2, right? Here's base 1, there's base 2. You're going to use both of these, right? However, this one right here, this is the right base of this first one, but it's also the base of that one. All of the middle bases, these are used twice. The ones on the outside are used once. So what we're going to do is plug in all of these values in for x. So it's going to be e to the first plus, I'm going to put a 2 around this, e to the 1.5 plus e to the second plus e to the 2.5 plus, now notice I ended the parentheses because these are the only ones that get used twice. And then the last one, 3, gets used once. All right, and then we're going to plug that in and see what we get. All right, and we got 17.7276. All right. All right, so now to use the calculator to find the exact value. All right, so to use a calculator, all right, you get your calculator screen and you're going to hit menu, 4 for calculus, 2 for numerical integral. So menu 42. And then you're going to plug in your equation. All right, so it's going to be from, that's 1, right? That's 1. That's 3. We go e to the x dx and hit enter. And we get an answer of 17.3673. All right. All right, so 17.3673. whatever the exact values should be closer probably to the trapezoidal approximation. Okay. Now, to find the percent error for an approximation, all right, what you're going to do is you subtract. So first we have to do it for, let's do it for rectangle. All right, to do it for rectangle, you're going to subtract your two answers. The answer that is what you got minus the answer what the exact value is. So 22.0694 minus 17.3673, and we divide by the actual 17.3673, and then multiply that by 100, and that is your percent. All right. So if we, all right, you get a percent error of like 27.07%. Okay. If I were to do the same thing for the trapezoid, all right. So in the calculator, what you should be plugging in is this minus that. All right. So if I do that real quick on my calculator, I get like 0.3603. Now I'm going to divide it by that number of 17.3673. And then once I do that, I'm going to multiply it by 100. And that gives me an answer of 2.07%. All right. Notice trapezoid, much better percent error than it is rectangle. So we knew that from before. All right. All right. So we have another example where we're going to use a rectangle approximation and we're going to use a trapezoidal approximation using a chart this time. All right. So for a rectangle approximation, n equals 5, and we're going from -2 to 18. So if we did 18 minus -2, that's going to be 20. So delta x is 20 over 5, which is 4, which is exactly what we have here. So all this is that's our delta x is 4. So 1/2, whoops, not 1/2. It's our delta x, which is 4. Now I need to put in, it's a right sum. So here's my first rectangle. I'll use the right side. So I'm going to use all of these y values except for 20. So it's going to be 15 plus 12 plus 18 plus 28 plus 37. All right, plug that into our calculator, and we get 440. All right, let's erase some of this for the next one. All right, so now for trapezoidal. All right, trapezoidal, 1/2 is always on the outside. Then our delta x, which is 4. All right, so we have the 1/2, the delta x. So now remember, this goes in here once, plus 2 times all of these. All right, so these numbers add together, we get multiplied together twice, and then plus 37. Didn't feel like writing all those again. All right, put that in the calculator, see what we get. 406. All right, so there's 2 examples of one with a rectangle approximation and trapezoid approximation using a chart and using equation like we had number 1. All right, number 3. We are given the integral from 0 to 12 of f of x is 13, from 8 to 12 is 4. All right, so we're just going to go through each of these. All right, so if I know from 0 to 12 is 13 and from 8 to 12 is 4, what does that mean? It has to be from 0 to 8, to subtract them. It's 9, right? Because 9 plus 4 has to add up to 13. Whenever you have the same number top and bottom, the answer is always 0. All right, now C looks very similar to this, right? But we have the bigger number on the bottom. Whenever it happens, we take the opposite. So -4 is your answer. All right, this is the one that gives the most issues. Remember, we have 2 things on. We have to split this up into 2 integrals. Now, let's do this right side first because that's the easier side. From 8 to 12 is 4, but we multiply it by 4. So this is 16. This one here has nothing to do with f of x. This is just y equals 3 going through, there's the line, at 3. And we're going from 8 to 12. It is a rectangle, right? This is what we're finding the area of. So from 8 to 12, so you take from 8 to 12 is 4, and you multiply it by the height, which is 3. So it's the difference of these times that number. So 4 times 3 is 12. 12 minus 16 is negative 4. And that's our answer for that one. All right, number 4. All right, make a sketch of each of these areas and use geometry to find the exact value. Okay, so we have a line here, 2 plus 3x. It is not a horizontal line. It is a slanted line. All right, so it's going to cross at 2, has a positive slope, so looks something like that. I don't care exactly what it looks like. I mean, where it crosses, because I know it's going to be a trapezoid. It's going to go from 1 to 4. All right, so this is what we're finding the area of. So 1/2 height, base 1 plus base 2. Now, I need on the quiz to see all of the tests. I need to see this work. If I don't see this work, you're not going to get the full credit if I just see the answer. I need to see the full work. All right, so 1/2. The height is this. That's always the difference between these two, which is 3. The height of these bases you get by plugging 1 in for that x. So 3 times 1 is 1, plus 2 is 5. Then I plug this number in to here. 4 times 3 is 12. 12 plus 2 is 14. All right. So 14 plus 5 is 19. 19 times 3 is 57. 57 divided by 2 is 57 halves. And there's our answer. All right. This one, whenever it's a square root of a number minus the x squared, it is a semicircle with this as your radius. So we have a semicircle. That's 2. That's negative 2. That's positive 2. Now, we're only doing from 0 to 2. So I am doing from negative 2 to 0. So we are doing this part here. So this is not a half a circle. We're finding a quarter circle. So it's pi r squared over 4. The radius is the square root of that number, which is 2. 2 squared is 4. 4 pi over 4, which is just pi. All right, and that's our answer. All right, 5. Finding the average value of, missing a equal sign, f of x is 5x squared plus 3 and an interval of negative 1 to 1. All right, so what we are doing is we are doing from negative 1 to 1 of 5x squared plus 3. And the average value, all right, this means, right, the average value, after we evaluate this integral, we're going to multiply the answer by 1 over b minus a, whatever that is, okay? So we're first going to integrate, and we do 5x cubed. Once again, I would need to see all of this work. All right, 5x cubed over 3 plus 3x. And then I'm going to plug in 1 and negative 1. All right, so when I plug in 1, I get 5/3 plus 3. All right, minus, now I plug in negative 1, I get negative 5/3. Negative 1 times 3, that would be minus 3. But I distribute these negatives, and it's going to change it to positives. So I get 5/3 plus 5/3, which is 10/3. 3 plus 3 is 6. If I add those, 6 is really what? 18/3. 10/3 plus 8/3 is 28/3. Okay, so that's what this is. But I have to use this, 1 over b minus a. So that's 1 minus negative 1, which is really 1/2. So I multiply by 1/2, and I get 14/3, or 28 over 6, which reduces to that. So this 1/2 is this. okay? Because it's 1 over 1 minus negative 1, which is 1 over 2. All right, so you do what we normally do, then you multiply by the 1 over b minus a. All right. All right, 6. Evaluate the following using the first fundamental theorem of calculus. First fundamental theorem of calculus is what we just did in the previous problem without multiplying by the average value. All right, so in this case, I would need to split these up first. All right, split this up. I've done this a bunch of times now. So this is really the integral of 1 over x squared, which is x to the negative second, plus x to the negative fourth. So that integrates to x to the negative first over negative 1 plus x to the negative third over negative 3, which means I get, let me do a different color here, negative 1 over x minus 1 over 3x cubed. And we're going to plug in 2 and negative 1. All right. So I plug in 2, I get negative 1 half. Minus, I plug in 2, 2 cubed is 8. 8 times 3 is 24. So it's minus 1/24. All right, minus, plug in negative 1. Negative 1 over negative 1 is 1. Negative 1 cubed is negative 1 times 3, which is negative 3. But it's a minus, so it's going to change to a plus 1/3. All right, so we get negative 1 half minus 1/24. Distribute that's going to be a negative 1, but make sure that's also a negative 1/3. All right, so let's change this to all 24s just to keep it simple, and that's going to be negative 12 24ths minus 1/24 minus 24 24ths minus 8 24ths. It's all negative, so just add them up. 12 and 1 is 13. 13 and 24 is 37. 37 and 8 is 45. So negative 45 24ths, which we could reduce to 3 goes in those, what? Negative 15 over 8. All right. This one here. Integral of sine. Remember, you will be able to use your formula sheet that you've been using before. All right, you can use it. So you should know that the integral of sine is going to be, it's cosine, but it's not just cosine, it's negative cosine. All right, x. So we're going to plug in pi over 2, and we're going to plug in negative pi. All right, so just remember the unit circle here. Pi over 2 is up here, which is at 0, 1. All right, and negative pi is over here, which is at 1, 0. And cosine is x. So if we plug in this, we get the x coordinate of that, which is 0, minus, this is negative 1, 0. Cosine of x is negative 1, but there's a negative on the outside of this. So this is negative. So this is actually a, when you do, so this is cosine of x, cosine of negative pi is negative 1, but there's a negative on the outside, which makes it a positive 1. All right, it's a positive 1, but we're minusing it. So 0 minus 1 is negative 1. All right, so there's our answer. All right, what we got here? All right, solve the following differential equation. Give both general and particular solutions if possible. Okay, so we are going to integrate both sides, and we end up y equals x cubed over 3 minus x plus c. And this is what we call our general solution because it has a c in it. Now, there's no point here, so I can't find a particular. All right, same thing over here. This becomes y equals, all right, we have x plus 1 to the 1/2. All right. So in order for us to integrate this, all right, if we did substitution, right, u is x plus 1, du is just dx, all right, this actually works out okay to just do a normal power rule because there's nothing inside that gets integral, because we can rewrite this as the integral of u to the 1/2 du. 1/2 is what? 3/2, the 2 and a 3. So this is 2u, which is x plus 1, to the 3/2 over 3 plus c. This is our general solution. To get the particular solution, we use this. The 0 goes in for our x, the 5 is our y. So it's 5 equals 0. When I plug in 0 here, all this becomes 0 plus c. So c is equal to 5. So my particular solution is all of this. Y equals 2x plus 1 to the 3/2 over 3 plus 5. All right. All right, so now moving to the second page. All right, now number 8 on the sheet that you guys downloaded off of Classroom did not have this picture on it, okay? I put it as a separate attachment. Hopefully you guys saw that. If you didn't, this is what the picture should look like. So if you didn't see that, you could put this in here and try those out now. All right, so before we do any of this over here, what we want to do is we want to break this up and figure out the area of each individual shape. Remember, everything above the x-axis is positive, everything below is negative. So that first one is a triangle, all right? So we get 1/2 base times height. So the base is 3, the height is 2, so that's 6. Half of that is 3. This is a curve, so this is a quarter of a circle. So pi r squared, so the radius here is 2. 2 squared is 4. 4 pi over 4 divided by 4 because it's a quarter of a circle. This is just pi. Split this up into a triangle, 2 triangles and a rectangle here, or you could just do one big trapezoid. But I'm splitting it because I see some stuff over here that I might need to. I'm not sure actually. But let's just do it this way. 1 times 2 is 2. Half of that is 1. This is 1, and this is 2 times 2, which is 4. All right. So now you just go through, and what's from -3 to 2? Just add those together. So it's 3 plus pi. From 0 to 6, that's pi minus 6. Why? Because that's on the below the x-axis, so that's all negative. These are all negatives. All right, now notice, this is from 6 to 0, so I'm working backwards. You just take the opposite of what you just got here. So it's negative pi plus 6. All right, -3 to 6 is this entire thing. So we have 3 minus 6, which is -3, and a pi, so it's pi minus 3. All right, this is just like one of the ones that we have in the front where you have to split it up. So this first part is from -3 to 2, which we already have, which is 3 plus pi. 3 means that I am just, it has nothing to do with this curve. It has to do with making a horizontal line through 3 from -3 to 2 and finding the area of that rectangle. So you take the difference between these, which is 5, and multiply it by the numbers 3 because that's the height. It would be base times height. 5 times 3 is 15. So it's pi plus 18. All right. 0 to 6, absolute value means if something's negative, it becomes positive. So this -6 becomes a positive 6. So it's pi plus 6. All right. So for these problems, make sure you figure out the area of all these first, then do that. All right. All right, now a particle moves along the x-axis in such a way that its velocity in time t is given by this velocity equation. Okay. Now remember, when we do stuff like this, it goes from position to velocity to acceleration. Anytime you go left to right, this is derivatives. When you go this way, it's integrals. Okay. Now we won't need to worry about that until C and E, or C and D. But for these first part, when does the particle come to a momentary stop? Well, there's the velocity. It's when that equals 0. So you set this equation equal to 0. All right. So we need to factor this. You can use your calculator for this section if you like. All right. And you could do menu 333. Right. But hopefully you can factor this as well to 3t minus 2, t minus 5. All right. Which means when does it come to a stop? It comes to a stop at 2/3 of a second and 5 seconds. All right. Then to do what is it moving to the left, this is where we make a number line. And on that number line, we put 0 and then whatever other values we got, 2/3 and 5. And we plug in to the velocity to see if it's moving left or right. If it's positive, it's moving right. If it's negative, it's moving left. So when I plug in 1/3, let's say, 1/3 minus 5 is still going to be a negative. 1/3 of 3 is 1. 1 minus 2 is also a negative. Negative times a negative is a positive. If I plug in 1, 3 times 1 is 3 minus 2. That gives me a positive. 1 minus 5 is a negative. Positive times a negative is a negative. If I plug in like 10 positive here, positive here, positive times positive is positive. So what is it moving to the left? Wherever it's negative. So it is moving to the left between 2/3 and 5. So the easiest way to write that would just be to do interval notation, but I don't care if you wrote it like this. If you actually just write it out, write it as inequality, doesn't make a difference. All right, find the equation of the acceleration at a type t. Well, this is the velocity. To go from velocity to acceleration, we're going from left to right. That's just the derivative. So the acceleration is just the derivative of the velocity. So that's 6t minus 17. We were done. All right. Now, to do if you're given the velocity to get the position from right to left, you have to integrate. So we're going to integrate. So the position is going to be equal to 3t cubed over 3 minus 17 squared over 2 plus 10t plus c. Well, I can't have a c, though, in my position equation. So you need to use the information you're given in the problem, which is this, that the position is 3 when t equals 0. So if I plug in 0 for all of these, what's c going to end up being? It's going to be 3. So my final answer is 3 over 3. That cancels, so it's just t cubed minus 17t squared over 2 plus 10t plus 3. All right, so once again, this 3 comes from plugging 0 in there, and there, and this is set equal to 3, 0, 0, 0, c equals 3. All right, that's where that comes from. All right, what is the position when the acceleration is 0? So if I set the acceleration equal to 0, 6t minus 17 equals 0, I get t is equal to 17 over 6. And then what I would need to do is plug in 17 over 6 into the position equation and then plug that into your calculator, and you would get roughly negative 14.1574. All right, so we get negative 14.1574. All right, which, if you think about it, 17 over 6 is less than, what, 3 seconds? So at 3 seconds. So it only moved on the right anyway for a little bit, and then it's been moving to the left. So it makes sense that is a negative position. Okay. So the last ones are different types of integrals. All right, and there's a bunch of practice on here, obviously more than computer tests. Now, I will say, I will write this in a post, but I'm going to split this test up into 2 days. All right, probably one where it's calculator set stuff, one where it's non-calculator. So this isn't, you're not going to be able to do all this obviously in 40 minutes. All right, so to do this integral, now all of this is going to be substitution. Here we're just going to find the integral of each individual one. So we get 3x cubed over 3 All right, move this up top is really the same thing as 5x to the negative second, which is 5x to the negative first over negative 1. All right, we'll fix that in a second. And then this is the same thing as 2x to the 1/2, all right, which is negative 2x to the 3/2. That's a 3. But we multiply and by the reciprocal, so the 3 goes on the bottom and the 2 stays there. All right. So my answer, these cancel, is x cubed minus 1 over 5x minus 4x to the 3/2 over 3 plus c. All right, there's A. All right, so we have a trig problem, multiple trig things in here, and they have different powers. So we take the trig with the highest exponent. So our u is going to be tangent 5x. Our derivative of tangent, remember, you could use your formula sheet. So it could be a good idea if you could print it out, have it printed out, or have it somewhere handy that you can look at. Secant squared 5x times 5, chain rule, right? Derivative of the outside keeps the inside the same times the derivative of the inside. Gives you that. I need to have all of du needs to be in my integral. So secant squared 5x dx is there. I am missing a 5. All right, missing a 5. So I put a 1/5 on the outside. Tangent 5x is my u. It's u cubed du, right? All of this is my du. So that's all du. That's my u cubed. All right, remember, we have a trig problem with substitution. If you have if trig's in your u, it's probably not going to be in your integral. So I just integrate this 1/5 u to the 4th over 4 plus c. All right, so that is, the final answer is tangent 5x to the 4th over 20 plus c. There you go. All right, we got another trig one, and we have just one trig function. So we have one trig function. Our u is whatever comes after the trig, which is x to the 5th. We take the derivative of x to the 5th, which is 5x to the 4th dx. I need all of this. I have an x to the 4th. If I didn't have an x to the 4th, I couldn't do this problem because we can't add in variables. I need to add a 5 in, all right, which means I get a 1/5 on the outside. All right, all of this and that's my du, and I'm left with sine. Well, what's the integral of sine? Once again, you can look at your thing, but it's negative cosine u du. All right, and then you just substitute your u, and you get negative 1/5 cosine of u, which is x to the 5th, plus c. There's your answer. All right, scrolling down. Next integral. We have a trig function here, but it doesn't have anything after it besides just x, so we don't need to do substitution. So we're just going to do each individual one here. What's the integral of cosine? All right, well, it's sine. So sine x plus 2x squared over 2 minus 3x plus c is your answer. The only thing is you would cancel that out. I don't feel like rewriting it. So sine x plus x squared minus 3x plus c is your answer. All right. Now for E, we have something underneath a radical. All right, some increasing. We're going to have to use substitution, and we take whatever is underneath on the inside is our u. So that's our 3x cubed plus 2. Our derivative of that is 9x squared dx. And we have an x squared. We have our dx. We're missing a 9. So we put a 1/9. So all that in blue up here, this that I underlined, that's my du. So the only thing that's left is the square root of this, which is the square root of u, which I'm going to rewrite as u to the 1/2. All right. So it's when I integrate, you get 1/9 u to the 3/2 because I'm multiplying it by adding 1 to it, sorry. And then do the reciprocal. So the 3 goes on the bottom, the 2 stays on top. So a final answer of 2, 3x cubed plus 2 to the 3 halves power over 27 plus c. This is your answer. All right. F, we have trig again, and we have two trig functions with different exponents. So we take the one with the highest exponent, all right, the highest exponent. So our u is going to be cosecant 3x. I don't like that. That was too du. I like our yellow. The the derivative of cosecant, you can look that on your formula sheet, is negative cosecant, keep the inside the same, cotangent, keep the inside the same, times the derivative of the inside, which is, inside is 3x, so it's 3 dx. All right. So I need all of this. All right, well, there's cotangent 3x dx. I'm missing a 3, so I'm going to put a 1/3 on the outside. But I also need cosecant 3x in here. Well, here it is, but there's 4 of them. So when I rewrite it, and first of all, I need a negative, sorry. There's just going to be 3 of them left. So instead of being u to the 4th, it's u cubed du, which is negative 1/3 u to the 4th over 4 plus c, for a final answer of, just plug it in, so that's negative 1/12 cotangent, sorry, I lied, cosecant 3x plus c. Sorry, he was right there. Right. Or negative cosecant, oh, and it's to the 4th. I'm an idiot. Negative cosecant 3x at 4th all over 12, or you put it out front. Doesn't make a difference. All right. All right, so now we got another trig. All right, we have another trig one and 2 trig functions. However, the difference here is that they have the same exponent. So we are going to make u whatever comes immediately after, which is 1 over x, which is the same thing as x to the negative first if I'm taking the derivative of that, which is negative x to the negative second, which is really negative 1 over x squared dx. All right, so I have all of this. There's this and that. I'm just missing a negative. That's it. So when I rewrite it, it's negative secant u tan u, which if you look on your formula sheet, the integral of secant u tan u is just secant. So it's negative secant u du. So negative secant, what was my u? It was 1 over x plus c. There's my answer. All right, H, really tough one. Integral cosine x. There is nothing. There is no anything besides x, so there's no substitution. Just look on your formula sheet. The integral of cosine is sine x plus c. All right, like those. All right, this one here, when you see just one trig function in the bottom, think about what's the reciprocal of cosine. The reciprocal of cosine is secant. So I can rewrite this as secant squared 5x dx. Now I could do my u and du. It's one trig function, so I make it 5x, because that's what comes after it. Du is 5 dx. Sorry, it's going a little slow here. This hand's a little sore. So I have missing a 5. So it's 1/5 integral of secant squared u du. All right, and the integral of secant squared is tangent. And since my hand is getting sore and I don't want to rewrite anymore, it's tangent u plus c, but I'm just going to put the u right in there, which is 5x, and I get that. All right. Down to the last three. All right, so for J, we are going to make u 4x squared minus 1. Our du is going to be, what is that, 8x dx. So I need to add an 8 up there, which means I need to put a 1/8 integral. All right, so all of this is du, right? So that'd be du over, this is u cubed, which is really u to negative third. So it's 1/8 u to the negative second over negative 2 plus c. So my final answer would then be, all right, it's going to be negative 1 over 8 times 2 is 16. Move this to the bottom, which is 4x squared minus 1 plus c. There's my answer. All right. Okay, two trig functions, different powers. So we're going to take the one with the highest exponent. So that's sine 4x. So u sine 4x is my u. My du is going to be the integral of sine is cosine. So it's cosine 4x times 4 dx. There's that. I'm just missing a 4. So all of the purple there is my du. All right. So 1/4 integral of u to the 5th du, which is 1/4 u to the 6th over 6 plus c, for a final answer of sine 4x to the 6th power over 24 plus c. All right, finally, last one is L. All right, this is the kind where we need to split up. All right, we split that up, and let me just put a line here. That's x over x to the 4th, which is 1 over x cubed. And this is 3 over x to the 4th, right? Well, we're going to rewrite that as x to the negative 3rd plus 3x to the negative 4th. And that's what we're going to have to take the integral of. All right. So the integral of x to the negative 3rd is, let me just block this out here. So this is x to the negative 2nd over negative 2 plus 3x to the negative 3rd over negative 3 plus c. All right, those 3's are going to cancel. So here is going to be negative 1 over 2x squared minus, because of this negative, 1 over x cubed plus c. And there's our final answer. All right. So I know this review is long. All right. A lot of stuff going on here. Please let me know if you have any questions. There is a good possibility that I just made a mistake going through and doing this. All right. So if you find one that you're like, Mr. Gillern, I think you might have made a mistake, please reach out and let me know, and I'll check to see who's right. And if there's any updates I need to make to the answer key, I'll let you guys know. All right. Like I said, I think I'm going to split this up in 2 days. But if you have any questions, let me know. And hope you guys are staying healthy. All right. Talk to you guys soon.